Hello guys and welcome. In this video I'm going to talk about prediction. So right now, as you can see, we can move our character, and if I stop this and go to the multiplayer play mode tools, we have the option to select the type of the network simulation. If we put it on unplayable internet, this is the worst kind of internet connection, so it's gonna simulate that. Now if I play this and when I try to move the character, it's actually gonna move with a lot of delay. So thankfully Netcode for Entity has client prediction built in, so you don't need to do anything about that. Netcode is gonna handle that. All we need to do is go to our player movement system, and this is the system that is moving the character. All we have to do is add update in group prediction simulation system group. So when we do that, if we go back and with the same bad connection, which is unplayable internet, if I play this, so when I move my character, it immediately gonna move. It's not gonna wait for the server, it's just gonna move. And you see, even on a bad internet connection, we instantly can move our character. And as you might notice, when I stop, it's gonna roll back, which means it's gonna jump to the position that server is declaring. That's prediction and rollback already built in and implemented. As you can see, it's just gonna snap back to the server position. And if we change the internet simulation on something better, so this is the worst and this is the best, so let's choose something in the middle, and now everything is smooth and predicted. So I like to talk about a couple of more topics. Let's take a look at the documentation. So we have a concept called prediction smoothing and another one, prediction switching. So I'm going to talk about these two options that we have in Netcode. So let's talk about prediction smoothing first. So I don't know if you noticed or not, here, let's put it on the unplayable internet and play the project one more time. Now you see when I move my character and when I stop, it's gonna snap back to the server position. So it's kind of obvious, and it only happens on a slow connection, by the way. So basically that's when we can use prediction smoothing to remove that jump. So during the character movement, we're gonna slowly move our transform towards the position that server is telling us. So that way, when the rollback happens, the difference that we have with the server is not that much, so we're not going to notice a big jump. So the documentation has provided an example, and I'm just going to use that code. I've already made a few changes, but let's go ahead and do it. Here I'm going to create a new script, and I'm going to name it Client Prediction Smoothing System. So if I open this script, so let's change it to partial struct and use iSystem. Let's also add the filter to only run in the client simulation, and we also add the burst compile. Let's implement on create function, and here I'm gonna place a boolean to manually disable and enable the client smoothing, and if it's not enabled, we're gonna return. So first we need to register on a ghost prediction smoothing. So I'm gonna get the singleton for ghost prediction smoothing, and let's go and create an action. I'm gonna name it client transform smoothing action, and let's add burst compile. And this is the code from the documentation with a little bit of change. So as you can see, first I'm gonna create a sealed class to hold these two variables, maximum distance and delta. And then here there is a read-only portable function pointer called action. And if we go further down, here there is a smoothing action which takes 3 parameters. And then we're using the onSafe utility to point to a location of that data on our memory, which is, by the way, this is a onSafe operation. And here on create, we can register smoothing action. So if we go to the editor, we're probably gonna get an error. So let's go and try this. Here, as you can see, we cannot use unsafe code. So in order to use that, we should go to the build settings, in the player settings, and here in the player other settings, if we go further down, we should see a checkbox for allow unsafe code. So if we check this, the error should be gone. So I personally don't like to use this, but for now this is how the documentation says we should do it. Let's hope they're gonna find a better way to do it in the next updates of the netcode. But for now, if I play the project, I am getting this error because I'm trying to reach the singleton before it is created. So let's go to the client prediction smoothing system, and I'm also going to create the update and a boolean called registered. And here I can add a state required for update ghost prediction smoothing, and here we say if registered or if it's not enabled, and we can get rid of that. Now let's go back to the Unity, and if we play the project, now I guess we should have a smoother rollback, which to be honest I don't notice any difference. Maybe we should play around with this numbers, but basically this is how you could do it based on Unity documentation. So now that's prediction smoothing. Let's go and take a look at the prediction switching. This is actually something useful. So if we take a look at our ghost prefab here, this is the player, you see that here we have a supported ghost modes. So we can have it predicted or interpolated or both of them together. And in order to use prediction switching, you need to put this on all, and here we have interpolated, predicted, and owner predicted. So interpolated basically is whatever the server says goes. Client only receive the position from the server and move to that position. Owner predicted is that the owner changes position and doesn't wait for the server, and later it's gonna check with the server, and if there is a difference then it's gonna roll back. So this is for the owner of that entity, but predicted is for all the clients. You might ask, what is the difference between these two? When we should use any of these? So if you have a first-person shooter, for example, you're gonna use owner predicted because only the owner should have the ability to move your character, your first-person character. But let's say you're creating a football game, or as the Americans call it, soccer. So let's say you want to instantiate a soccer ball in your scene. So this ball is going to be pushed around by all the players. Let's say every player in the game is a client. So there's a bunch of clients in the game pushing the ball around. That's when you need to put the ball on the predicted. All other players are on the owner predicted, but the ball is on the predicted, because literally every other client needs to have the ability to move the ball instantly. That's the kind of situation you want to put the entity on the predicted. So for our character prefab, I'm gonna put it on owner predicted, and let's go ahead and also add a capsule collider and a rigid body, and also let's make sure we have Unity physics package installed. So here it is. I don't have it installed, so let's go ahead and do that. And now let's select the player again, and let's go ahead and change the mass to 100, because later we're going to create a ball and we want our player to be heavier than the ball so it could move it around. And let's also create a sphere here in the 3D object. Let's name it soccer ball, and it already has a collider. I am also going to add a rigid body, and let's make it a prefab so we could attach ghost authoring component. So let's select the prefab, and here I am going to put it on all, because as I mentioned, we're gonna switch the soccer ball prediction type. So we're gonna put it on all. So by default, let's put it on predicted, and we're gonna leave the rest. So right now we have a soccer ball in the scene. Let's also create a component data for it. So here I am going to create a script, and inside this script, I'm also going to create an empty component data. It is just gonna be a tag to identify the ball in our scene. So we're gonna attach it to our entity using a baker, and that's it. Now we can go ahead and attach the script to our soccer ball in our scene. Let's also apply the changes. Now our entity has also a soccer ball tag on it. So let's dive into prediction switching, what it is and why we should use it. So prediction is going to be heavy regarding the bandwidth. As you can see, there's a note about it. The rollback and prediction and stuff like that is not good. So you shouldn't have a lot of entities in the scene that are predicted. That's gonna put extra pressure on your network. So what you're gonna do here, for example, if I choose the soccer ball, let's actually choose the prefab which we can change stuff. So we're gonna calculate the distance between the ball and our player. So if this distance is too high, then we're gonna switch it to interpolated, switch the ball to interpolated. But if the player is close and it's about to interact with the ball, we're gonna put it on predicted. So basically we're gonna switch between interpolated and predicted, and that's called prediction switching. This way we're gonna reduce the pressure from our network. Before we implement the prediction switching, let's actually run a few tests. So let's change the player. I think there's already a capsule collider here. So I'm gonna remove that, and instead of the capsule collider we just placed, let's use box collider, and let's apply the changes to the prefab. So if I remove this and put the soccer ball on the interpolated, if we play the project, if I go towards the ball, you see that our character is tripping. It's about to fall down whenever it's interacting with the ball. As you can see, it's gonna affect the character rotation and it's making the character tripping, as you can see. So the reason is the ball is on the interpolated, which means the client has no effect on the ball on the client side. So sometimes the ball is actually behaving like a static object, which when the player interacts with, it's about to fall. So if we put this on predicted and play the project again, now the ball is no longer like a static object, and it's going to be predicted by the client. As you can see, it's not gonna make our character tripping over it. This is because the character is actually affecting the ball on the client side. So we want the ball to be interpolated when we're not interacting with it, but when we're about to interact with it, let's say there is a radius around the ball, when we enter that radius, we want to change it to predicted. So that's called prediction switching. So to do that, let's go ahead and create a system. Here I am going to name it client switch prediction system. Let's open this up, and here we're going to change it to partial class, and we're going to add the filter to only run on the client simulation. I'm going to add two variables, prediction radius and prediction radius margin. So if we have a circle like this, let's say this is our radius, we don't want to create a system which is keep jumping between interpolated and predicted the second character is crossing this line, because this is a thin line and character could cross this multiple times in a very short time period. So what we're gonna do, we're gonna also define a margin like this. So this is gonna be another circle. So whenever a client crosses this line, we're gonna switch it to predicted, and whenever it leaves this line, we're gonna switch it to interpolated. So let's go to the script. That's where the radius margin comes in. I'm also going to create two native lists, and I'm going to use them to store the entities that I want to either convert to predicted or to interpolated. So let's create the on create. It requires soccer ball data component to update, because we're gonna switch the soccer ball prediction mode, and I'm gonna initialize the native lists, and I'm gonna dispose them on destroy. Now in the update, so first let's get a reference to the ghost prediction switching quiz. We're gonna get the singleton and also define two variables, two predicted and two interpolated. We're gonna assign the values to the native lists. We're gonna write the logic here, but before we do that, let's jump to this point. First, we're gonna clear those lists, and if we don't have a player data with local transform attached to it, we're just gonna return. By the way, the player data is the component data we are attaching to our player using player script here. This is the player data. So if we don't have any player data in the scene, which means our player has not been instantiated, so we're just gonna return, because we need to access that player entity and the local transform of that player to calculate the distance to the ball. After everything is good, I'm going to define a variable to predicted radius. It's going to be equal to the prediction radius we have up here, and we're going to get the player position by getting the component data on the player entity. And here I'm going to create a query, and I'm going to look for entities with soccer ball data attached to them, but without predicted ghost attached to them. I'm gonna get the local transform of those entities. Then I'm gonna calculate the distance between our player and that soccer ball entity. So if the distance is less than to predicted radius, which is here is 5, then I'm gonna add that entity to this list, to predicted list, which means I'm gonna convert anything in this list later to predicted. Then let's create another variable to get the radius for the interpolated. It is going to be prediction radius plus margin. So 5 plus 1 equals to 6. So that's going to be the value inside this. By the way, the reason I'm defining the variables like this and I am not just directly using that is because I'm going to use these variables inside this for each, which I'm going to get an error if I directly use these references. So I'm just going to create a local variable first, and then I'm going to use that instead. Now if I do another for loop, and this time I'm going to look for entities with predicted ghost and ball data. For those entities, if the distance of those entities with my player is greater than interpolated radius, which is 6 in this case, I'm going to convert them to interpolated because they're far away from the player. Now let's go up there, and here I am going to do a simple for loop on toPredicted.length, and if it has a ghost instance, then I'm going to use ghost prediction switching quiz, convert to predicted qui, and I'm going to add the toPredicted I as the target, and also for the toInterpolated list, do the same thing here. I am going to use the ghost prediction switching quiz, convert to interpolated qui. That's pretty much how we are going to switch between interpolated and predicted. And now let's go and try to test this. Before we do that, let's change this to soccer ball data actually. Now let's also change the to predicted duration to 0, and I'm also going to change this to 10 and maybe this to 5. Now let's go to the editor, and if I play the project, now if I get close to the ball and go to the entities hierarchy, and in the client world, if I select that, there should be a predicted ghost component attached to the ball. Now if I go far away from the ball, as you can see, the predicted ghost was removed. And let's go back. Here it is, attached, removed. And just like that, it's switching between predicted and interpolated. So I guess this is it for this video. I hope you enjoyed the series so far. Please make sure to like the video and subscribe to the channel, and thanks for watching.